All right, so 8.7, solving inequalities. For the most part, when you solve an inequality, oh my goodness, I feel like I'm on stage with this light. So for the most part, solving inequalities is the same as solving an equation, which is what we just took the test on. And I don't know if you guys saw, but I finished grading your test and put the grades in the grade book. You can also go back into Google Classroom and reopen the test if you want to see like what you got wrong. And let me know if you have any questions. Some of you guys already saw. So anyway, so solving inequalities, we're going to start with very simple one-step inequalities, which might seem like, well, we already know how to solve harder equations, but there's a reason I'm starting with one step, and because you'll see when we get there. So let's start with just adding and subtracting inequalities. One thing to remind you of before we get started, as I said in the video yesterday, if your variable is on the right side, I highly suggest you rewriting it at the, so that it's on the left side. Now, when we do it with solving inequalities, I usually solve the inequality first and then rewrite it right before I graph it. Some people don't need to rewrite it. Some people are fine to graph it, whether the variable is on the right or the left. So this is not a requirement. It's just a suggestion for those of you that find it easier to graph when the variable is on the left, which I'll show you an example of why it might be easier to do with the variable on the left if you're not sure whether or not you should do it. So for this first example in your notes, it says 5 plus x is greater than -2. So to solve for x, you do the exact same thing that you would do if this was an equal sign. The only difference is that it's a greater than sign. So we do -5 on both sides, cross out the 5, and you get x. And instead of equals -7, we just write x is greater than -7. Okay, so this one's on your notes. Write that down. Same steps. The only difference is instead of an equal sign, we have a greater than sign. More than likely, at some point, we will all accidentally put equal signs. You have to get used to writing something other than equal sign. We're so used to equal signs that I'm sure at some point we all will accidentally put an equal sign. The graph for this, you really only need to do 3 numbers is fine. I like to put the number, whoops, that's negative, sorry. I like to put the number that is my answer in the middle, and then I just do one bigger and one smaller. Would this be an open or a closed circle? Any volunteers? Preston.
Open.
Open. Open circle, arrow to the right or to the left? Mario, are you raising your hand? Go ahead.
To the right.
Yes, so this is why it's easier if the variable is on the left. The arrow goes the same direction as the inequality symbol. So it's really easy if your variable is on the left to know which way to go. So greater than goes to the right, as long as the variable is on the left-hand side. Any questions about that first example? All right.
So, sorry, my computer is kind of lagging. So whenever you do that, like the inequality sign, will it like always point the right direction, or is that just like
as long as the variable is on the left-hand side? So here's an example where the variable is on the right, and I'll show you how you can, at the end, reverse it so that that is always the case. Okay, so I'll show you in this example. So we have -4 is greater than or equal to r minus 10. Solve it first, so add 10 to both sides. Cross out the 10. -4 plus 10 is 6. Greater than or equal to r. So here's a perfect example of what I was just talking about. Some people are fine reading it backwards like this and still being able to graph it correctly. Personally, I think it's easier when the variable is on the left, not the right. So if you want to, when you're done, like after you get the answer, you can rewrite it so that the variable is on the left. So if 6 is greater than or equal to R, that means R is less than or equal to 6. Okay? You don't have to do this, but when you go to graph it, like this, if you were just looking at this answer, the inequalities, the number line, closed circle, the arrow does not go the same direction as the inequality symbol in this answer because the variable is on the right. So this one is, it's fine to leave your answer like this, but in terms of graphing, it's like backwards. Now, some people actually understand it better that way, which is just kind of interesting. Like some people read it differently than others. I read it as R represents all of the numbers that are less than or equal to 6. So it goes this way. Some people like reading it as 6 is the biggest, is bigger than all of the other numbers, so they go that way. So it's totally up to you, like which way makes more sense to you. But the answer is that the graph would go that way. Does that make sense? The difference between like when the variable's on the right or the left. Totally optional. Like I said, you don't have to rewrite it at the end, but if it helps you for graphing purposes, then I suggest rewriting it. Okay, it's totally optional. You don't have to do it. Any questions about that? Oh my goodness. Okay, so here is where it gets a little tricky. Adding and subtracting is nice because it's almost exactly the same as when we did it with equations. With multiplying and dividing, we have certain like rules we have to follow. So let me go over the rules. I think you have some blanks on your notes to fill in also. I'm going to go over the rules and then I'll show you several examples so you can understand how to do it, and then I'll also explain why we have to do it too. So here's the rule. If you multiply or divide by a positive number on both sides of your inequality, the inequality symbol stays the same. Okay, so kind of like we just did with adding and subtracting, if it was a less than symbol in the beginning, it was a less than symbol at the end. As long as you multiply or divide by a positive number, nothing changes. If it starts as a greater than, it ends as a greater than. However, if you multiply or divide by a negative number on both sides, you have to flip the inequality to the opposite direction. I don't know if you guys can see that, it says opposite. Okay, so if you end up solving and multiplying by a negative number or dividing by a negative number on both sides, if it started as a greater than symbol, it ends as a less than symbol. Okay, and this is different from what I was just explaining about reversing the answer so that the variable is on the left. This is totally different from what I was just talking about. This is not optional. If you multiply or divide by a negative number, you have to flip the inequality. Okay, and I'll show you why when we get to an example, but I just want to make sure I go over both of the rules first, and then I'll show you some examples. Does everyone have the blanks filled in on your notes? All right. Okay, so let's start with a positive. The key for really the key is knowing which number causes the flip. Okay, so let me just show you this example. 2x is less than negative 12. To solve this, you divide both sides by what number? Caitlin?
2.
2. Okay, so the rule is when you multiply or divide by a negative number, the number we're talking about is this number right here. If you multiply or divide by a negative number, you flip the inequality sign. 2 is not a negative number, so nothing is going to change here. Okay, so 2x divided by 2 is just x. Negative 12 divided by 2 is negative 6. It has nothing to do with whether your answer is positive or negative. Okay, let me say that again. Whether or not you flip the inequality sign has nothing to do with whether your answer is positive or negative. It is if this number is negative. Okay, since this number is positive, it stays the same. So nothing changes. We divided both sides by positive 2, so nothing changes. To graph, put an open circle above the -6 because it's just less than. And less than goes to the left as long as the variable is on the left, which it is. Little side note, be careful when you're drawing your number lines with negative numbers. People tend to write them in the wrong order. So just be careful. Negatives go backwards because they go to the left as they get smaller. The numbers look like they get bigger. Okay, so any questions about that one? Divided by a positive 2, so nothing changed.
Scholar,
Go ahead.
I glitched out and I missed almost all of what you just said.
Okay, remember what I said at the beginning. I'm recording this, so I'm not going to repeat myself just because we have less than a normal class period. So I will email you the recording and you can go back and watch the part you missed, okay? Just for time's sake, I don't have time to go back and repeat myself too many times because I want to make sure I get through everything. So I will send you, was that Preston?
Yes.
Okay, I'll send you the recording then you can go back and watch that example, okay? All right, so this is the next example. It's almost exactly the same, except instead of a positive 2x, I made it a negative 2x. Okay, so instead of dividing on both sides by a positive 2, we would have to divide both sides by a negative 2. Okay, so here is the difference between the one we just did and this one. Like I said in the rule, if you multiply or divide by a negative number, it's the number you're multiplying or dividing by. That's this number. If that is negative, whatever our original inequality symbol is, has to reverse. Okay? So here's what happens. -2 divided by -2 cancels to just a positive x, 1x. -12 divided by -2 gives us a positive 6. And instead of a less than symbol, I'm going to do this really big and bold and in red. It reverses to a greater than symbol. I will show you and tell you why momentarily. But that is very important. It completely changes your set of answers. The numbers that are less than 6 are completely different than the numbers that are greater than 6, right? It's literally the complete opposite set of answers. So you have to flip it. Just a graph really quickly. Open circle on a 6. This one goes to the right because it's x is on the left and it's greater than, so it goes that way. Does anyone think they know why we have to do this before I tell you? Anyone want to try to guess or hypothesize, I guess, why we have to flip the symbol? Jaden, go for it. Give us your thoughts.
Is it because like negative, like, never mind.
Okay. I'll give you, go ahead, Mario. Give it a try.
Is it because since you're switching it from a negative to a positive, you have to switch that too?
Yeah. Basically, when you multiply or divide by negative, you're reversing, you're making it the opposite of what it was before. So if it was positive, now it's negative. If it was negative, now it's positive. So yes, that's basically the reasoning, is because it makes it its opposite. So you have to make everything the opposite. Also, just to show you, to prove to you that I'm not just making this up to make your lives more complicated, because you guys know I would never do that. Let's say you forgot to flip it and you wrote your answer as x is less than 6. Okay, someone give me any number that's less than 6.
5.
What?
5.
4.
5. Okay. If I take the number 5 and I plug it in here, -2 times 5 is -10. Is -10 less than -12? Is -10 less than -12? Yes
Yes,
or no?
it's less than -12.
-10. Is it less than?
Greater.
It's greater
It's
than. I'm
greater than-
sorry.
Right? I know it's negative, so you have to be careful.
Yeah. My
No.
brain is wired backwards.
That's a false statement. So numbers less than 6 don't work. So there's another reason. If you forget to flip it, all of the answer choices that you're saying are the solutions actually don't work at all. Numbers bigger than 6 work, like 10. If I plug in 10, -2 times 10 is -20. -20 is less than -12. Okay? So 2 reasons why you have to do it. One, like what Mario said, when you multiply or divide by negative, it makes it its opposite. And 2, because if you don't, all of your answers are wrong. So that's another good reason for you. Okay? All right, here's what I want you guys to do. Oh, I thought I had more than that. Oh, here it goes. Okay, I'm gonna number these 4 problems, and I just want you to type directly, privately to me in the chat, which of the 4 problems would you have to flip? Okay, so number 1, 2, 3, 4. Which ones would you have to flip? I won't even tell you how many correct answers there are. So which ones would I have to flip because of multiplying or dividing by a negative? 1, 2, 3, or 4. See if you guys can figure it out. Jaden, direct message privately to me in the chat, not to everybody. You guys are going too fast. I can't keep up with you guys. Try to type them both at the same time. Ashley, good. Olivia, good. Some of you guys only sent me 1, and the 1 that you sent was correct. And now my chat is lagging. I can't. Hayden, yes. Caitlin, yes. Mario, and Justin, and Nathan, one of those is correct. Justin Porter, sorry. I'll give you a hint. There's 2. A lot of you got one of them, which was this one, number 3. That one is correct. Most of you got number 3. There's one more. Now, just to clarify, I'm not talking about like which one would you want to rewrite to put the variable on the left. Like this one, if you wanted to rewrite it at the end to put the variable on the left, that's not what I'm talking about. Okay? What I'm talking about is which one would you be multiplying or dividing by a negative that would cause your inequality symbol to have to flip the other direction. Like this one would have to be this as our answer. What is the second one? Let me see. I forget who was someone that got it right. Yes. Braden, Mario, Nathan, Nathaniel. Good. It is number 2. Number 2 it is. Number 4, it can't be number 4 because everything is positive. There are no negatives in number 4 at all. So that one can't be. And number 1, you would be dividing by a +7, so that wouldn't cause it to flip. Okay. Number 2, you would have to multiply both sides by a -2/1. So we're actually going to go back to our notes and do one just like number 2. Okay, so let's kind of go back and do one like that. This one. This is, I think, the last one in our notes for today, which is good because we only have about 4-ish minutes left. All right, so here's a tricky one. The variable's on the right, and it's a fraction, and it's a negative. So if I'm solving this, what would I have to do to both sides to get the x by itself? Caitlin, go ahead.
You would have to do, you would have to multiply the negative 2/3 times negative 3 seconds.
Right, so you flip it and you multiply on both sides by the reciprocal, making sure we keep it negative. Okay, so this one's tricky for a lot of reasons. That is nice because that cancels and leaves just x. This, the 6 and the 2 can cross simplify to a 1 and a 3. And then we have a negative 3 times 3, which becomes negative 9. What inequality symbol goes in between the negative 9 and the x? Greater or less? Sid?
Less than.
Yes. So since this number that we multiplied by on both sides is negative, you have to reverse this. Okay, now. So that's reverse. That's what I meant by flipping. Now, here's another tricky part. When I go to graph this, if you're someone that prefers to read it from left to right with a variable on the left, guess what? Then you can not only flip the inequality sign, but you can rewrite the whole answer so that x goes on the left. You don't have to do this, but if it helps you for graphing purposes, how could I rewrite my answer? X is what? Mario.
Greater than?
Yeah. So this is tricky. It starts as greater than. We flip it to less than, but then if you reverse your whole answer, like if you reverse everything, it actually reverses back to greater than. But that's only if you choose to do this. You don't have to do this. Okay? If it helps you for graphing to know which direction the arrow goes, great. If you don't need to do this, then you can skip this and just leave that as your answer. Okay, so there's kind of a lot going on here. It seems easy at first when we first started with adding and subtracting, but the multiplying and dividing kind of makes your head spin a little bit. It's always a little bit tough at first to get used to. What I suggest on your homework, guys, is looking at the problems first, trying to pick out the ones that you think you're going to have to flip the inequality sign for, and like circling them or putting a star by them. So when you get there, you don't forget. I like to do that first, like, okay, I'm going to have to flip this one, and this one. And then you can solve them, and then you're like, don't have to think about it again. So yeah, just be careful. We're going to be doing more of this on Monday. So try your best on your homework. We'll go over some more on Monday. And yeah, if you have any questions, you can join my tutorial Zoom today if you're working on your homework and you're stuck, okay? Let me end this recording quick. Does anyone have any questions they want me to go back over, or anything that can help, that I can help with?
Can you post the homework answer key for last night on Google Classroom, because the screen went black when I was looking at it?
I will email it directly to you. Is that Brayden?
Okay. Yeah.
Okay. Yep. All right, if you don't have any other questions, you are free to go. Have a great weekend. I will see you all on Monday.
You too.
Bye.
Bye.
Thank you, Mrs. Heller.
Teddy, we said hi.
I will.